Yeah, cool. Thanks everyone for coming to my talk. I'm going to talk to you today about some of the work I did over the summer on searching for phenomenal consciousness in language models. Um, the TLDR of this project is basically that I took one of the indicator properties from the Butler and Long AI consciousness report from last year and tried to answer the question of whether or not today's language models satisfy this property, therefore updating us on whether language models today or future could in principle be conscious, um, with the answer of maybe. Um, yeah, so to start off with, what is phenomenal consciousness? Um, yeah, I think the word consciousness has a whole bunch of baggage attached to it. It's used quite differently by different people in different contexts. Sometimes it's used synonymously with intelligence or agency. Sometimes it points to some kind of self-reflection or self-awareness. Sometimes it's just used to distinguish between being awake and being asleep. But the kind of consciousness I'm interested in is roughly what is usually called phenomenal consciousness, which for our purposes we can uh, define using Thomas Nagel's definition, which goes something like a being is conscious just if there is something that it is like to be that creature, i.e., some subjective way the world seems to appear from the creature's mental or experiential point of view. So this is just pointing at this idea that there's like some internal experience going on. The lights are on inside. Um, so throughout this talk, when I use the word consciousness, I will be referring to the idea of phenomenal consciousness in this way. Um, why do I care about this kind of consciousness? It's because I consider this to be the main condition for moral patienthood, in that we should give moral consideration to a thing if it is conscious, since consciousness is required for it to have a nice time or a non-nice time. I think most of us have this intuition at least some degree, so I'm not going to try and convince you of this here. Um, and I might as well mention that there's a whole bunch of metaphysical debate about whether or not um, there's actually a coherent question to be asked here, whether or not it actually makes sense to ask if something is conscious or not, um, with some real objective answer to it. This is a massive can of worms, and I'm not going to go into it here. For this talk, I'm going to assume that there is an objective fact of the matter, whether or not something is conscious, and that it's possible for us to work that out using some combination of science and philosophy. Um, why do I care about AI consciousness? It helps think about this. It helps to think about how the future could go if we turned out to be wrong about this question of whether or not AI is conscious. Um, in situations where they are widely deployed. The main motivation I've always had for this kind of stuff has been the worry of false negatives, where we have a world where we have many millions or billions or even trillions of copies of AI systems running and generating economic value in some way. But it turns out that they're actually having some internal experience and that they're having a bad time. Uh, and this would feel a little bit like we've created a subjugated race of digital slaves. Um, and in this situation, maybe like we would just never find this out because nobody has any incentive to like work out whether these things are conscious or not. Yeah, there's lots of parallels between this kind of story and like a factory farming story. Um, there's also the less well-known failure mode of false positives. I can also imagine a world where society believes AI systems to be conscious, leading to them being given more rights and legal protections. This isn't actually that hard to imagine since language models may end up being very good at convincing us that they're conscious. And this could pointlessly contribute to either gradual human disempowerment, uh, including humans being pushed out of the economy and democracy, or a sudden disempowerment via some kind of AI takeover. I think we can all agree that both of these would be bad. Yeah, another thing that I want to bring up about this is that I think that AI consciousness is actually quite central to the moral status of AI alignment. Um, I think when people typically consider the second species argument applied to AI to point at an X risk, I think this, in some sense, it's only really an X risk if we ignore any possible moral value that the AI um, thing or society that comes after us doesn't have any, yeah, if that doesn't have any moral value. Um, I think I think the usual AI doom stories tend to implicitly assume that we don't actually care about don't care about the welfare or don't care about what kind of value these AI systems could create. Um, yeah, and I think it just makes the whole thing very confusing, and I think it is quite important to work this out. Um, yeah, and the more I've thought about the path to impact of this AI consciousness research, the more I feel like society's attitude towards AI consciousness probably isn't going to be swayed much at all by any sciencey or philosophy arguments about it that would come out of this type of work. So I'm not actually that interested in kind of advocacy for AIs or things like this. I'm mostly interested in this question because I think it's kind of an essential consideration for cost prioritization. Like, what should we be doing? Um, I think it's central to the discussion of what a good future actually looks like. Um, yeah, so the goal of my project is to start looking for consciousness in today's language models. Um, some of you might think that this is kind of stupid because most of us agree that today's language models almost certainly aren't conscious. So we know in advance that we won't find anything, right? Um, but even though I don't expect to prove a language model to be conscious anytime soon, um, we need to start getting less confused about how to search for consciousness in AI systems now. We need to start building a science of AI consciousness. And science needs empirical feedback loops to make progress. I think AI consciousness is kind of roughly where AI safety was 10 or 15 years ago, um, where we're kind of very much stabbing in the dark conceptually because um, we don't have uh, anything to test our claims. Um, these days, AI safety is thriving with lots of work being done and lots of progress being made. Um, if we could find any way to connect AI consciousness to empirical observations, this could lead to a similar opening of progress in AI consciousness research. Um, yeah, and there's this other related benefit that learning consciousness relevant things about today's language models is still useful because we could find prerequisites for consciousness in current language models, which would update us about how likely future LLM-based agents develop full consciousness. So how do we translate the philosophical problem of consciousness into an empirical question? Um, since there's no consensus on what consciousness is, um, but we don't know nothing about what consciousness is. We have a bunch of theories of what consciousness is that have survived a whole bunch of philosophical scrutiny and have been shown to be consistent with a whole bunch of empirical evidence about the brain and the mind. So we could consider them much more educated guesses than randomly guessing. Um, uh, and a big a big bit of progress was made in this last year when Patrick Butlin and Rob Long created this big long report um, where they uh, where they surveyed neuroscientific computational functionalist theories of consciousness. and extracted these indicator properties from each theory. So these are all like, if we take one of these theories to be true, then each of these indicator properties would give us some kind of property or some kind of structural or causal or functional property that we would want to go and look for in the system that we're trying to answer the question about. Yeah, so each of these properties can in principle be translated into an empirical signature to look for in language models. So we actually have lots of empirical work to do here. We can try and work out how many of these properties are in today's language models. The more properties they have, the more likely they are to be conscious. And I've written a little equation down here to kind of try and capture this. Probability of an AI system being conscious is something like the sum over all theories of consciousness, where this P theory is kind of the philosophical question of like whether or not this theory is true. And then this P AI consciousness given theory is something that can be made into in principle, be made into a totally empirical question. So the kind of work that I'm interested in doing here is like working out what these numbers are. Yeah, so my project this summer, or the idea of what I was going to spend time on this summer, was to try kind of starting this program by zooming in on a single indicator property with the code name hot2 and asking, do today's language models have this property? I don't think there's anything extremely special about this particular indicator property. There's I can say some story about how this is like the most interesting one in this particular family of properties. But yeah, I'm actually not interested in this property specifically. It's more like the main value of this project is to kind of try out and see how smoothly an investigation like this can go, and what kind of conceptual or technical difficulties might come up in trying to answer a question like this. Yeah, so let's understand what this indicator property says so we can work out how to apply it to language models. Yeah, so this property, metacognitive monitoring, distinguishing reliable perceptual representations from noise. It comes from this theory called perceptual reality monitoring, which is a recent popular version of a higher order theory of consciousness. It has like a whole bunch of neuroscientific evidence behind it now. Lots of people think it's cool. It's Patrick's favorite theory, as far as I can tell. So like it seems like a pretty interesting thing to study. Yeah, and one nice thing about this PRM thing is that it's expressed in conveniently information processing terms. So it should be something that's in principle not so difficult to try to apply to language models. Yeah, so PRM gives a mechanistic account of how unconscious processes become conscious in the brain. It comes from the idea that neuronal activity in the human brain is very noisy. At any one moment, the visual part of your brain, for example, has neurons firing that represents all sorts of colors and shapes that aren't actually happening in the outside world. But they don't represent anything in the outside world. So it's not useful for you to become conscious of these neuronal signals. So PRM hypothesizes the existence of a mechanism within the human brain called the discriminator. And this mechanism monitors these patterns of neural activity, picks out activity that it classifies to be representative of something in the outside world. something that it considers a signal rather than just noise, and imbues that signal with consciousness, wherever that thing may be. So the idea is that there is this mechanism that that evolved in human brains for this particular function, that gives thoughts whatever the secret sauce is that makes it conscious. Um, so, so the idea is, well, if there is a mechanism with a similar function in language models, perhaps that's making signals conscious in language models as well. So our goal now is to find out whether language models have something that looks a bit like a discriminator inside them. Yeah, so before going any further, I wanted to dwell on a meta point about how all this works, or how I uh, learned the hard way how this works. So in this indicator property, describing the discriminator or what it does, um, we have these words like metacognitive and perceptual. Um, these words are typically defined in like pretty uniquely human terms. For example, perception is usually defined by something like a process whereby sensory stimulation is translated into and organized into an organized experience. But it has this word experience in it. I'm like, well, if we're what the hell does experience mean when we're talking about language models? That's kind of getting a bit ahead of ourselves or something. Um, yeah, to apply words like these to language models, we need to find new definitions for these words in machine learning terms rather than in reference to the human experience. Um, Given this, there's kind of two ways to make progress with this. We could spend time trying to pin down exactly like how it makes sense to define these concepts in reference to language model things like inputs and outputs and activations, so that we could design experiments according to these definitions, which I've called here the theoretical direction. Or we could simply go straight to analyzing and designing experiments that capture our intuition about what these concepts are meant to mean, and assess, based on these intuitions, how much these experiments capture these intuitions about what these concepts are meant to mean on a case-by-case basis. I think either of these directions can be helpful because both of them kind of feed into each other. Precise definitions lead to better experiments, and problems with interpreting results from experiments lead to better definitions. And I think a great example of the interplay between these two kinds of progress can be seen in the literature on language model beliefs. Um, Basically, there was a bunch of attempts by machine learning researchers to measure beliefs in language models. A number of conceptual problems were pointed out by these attempts, which ultimately culminated in these lessons from these attempts being integrated into this philosophically rigorous and empirically testable definition that Harman and Levinstein come up with. I think this is a really nice paper. You should check it out. And the progress that seems to have been made in applying the concept of beliefs to language models kind of gives me hope that maybe we can make similar progress for these other quite human concepts like metacognition and perception. Um, yeah, so I spent my summer kind of bouncing back and forth between these two different kinds of work, and most of the progress I ended up making was on this empirical end. So I'll spend the rest of the talk kind of talking about this more kind of vague level of discourse. I'm talking just about like experiments that I read about that uh, kind of seem at least intuitively related to what we're looking for. Um, Yeah, so if we want to find a mechanism that looks like this discriminator thing in a language model, there's kind of two main like categories of approaches we could try out. Um, we could search internally, like under the hood. In other words, using some kind of mechanistic interpretability techniques to find like circuits that like have the function of a discriminator. Um, this kind of search will probably be the most useful, most strongest evidence that we could hope for in finding something like this. But it also sounds incredibly difficult. I don't know. I'm not an expert in mechinterp, and uh, yeah, I talked a little bit to people, mechinterp people about this, and they were like, "Wow, that sounds really hard." So I mean, maybe somebody in the audience who is a mechinterp person might be excited about a problem like this, and I'd be excited to um, yeah, to talk to you about it if you are interested in trying out looking for a discriminator using uh, mechanistic interpretability. Um, yeah, on the other hand, we could also look at related kind of capabilities, external capabilities, more of like an evals like approach. Um, and this feels relatively straightforward. I think this is where most of the low-hanging fruit in a search like this will be. So I spent most of my fellowship looking at this side of the search, the type of the search. Um, I spent time surveying the current literature on language model capabilities that seemed related to discriminator type abilities, and working out if any of these tell us anything about the presence of a discriminator. Um, yeah, so if we're going to go down the evaluations route, uh, we would need to ask what kind of tasks would require the kind of monitoring system that the discriminator has. Um, the most natural answer to this is to test language model confidence calibration. Um, this is to say, give the model something like some task, which we call the object level task, like from some benchmark or whatever, and then ask, how likely is it that you succeeded at that task, which we typically call the meta level task. And the signal we would be looking for is if the model is able to accurately predict when it does well and when it does badly. In other words, it's confident when it succeeds and it's unconfident when it fails. And theoretically, to perform well at this meta-level task, the model will have to make assessments about the reliability of its internal representations that it used using the object during the object level task. Which is the same type of function or would use the same kind of machinery as a discriminator. For example, if you ask a model to assess how likely it is that it got some question like, what is the capital of France, right? It theoretically has to look at that memory signal that says Paris and then make some judgment about whether or not that signal is a reliable representation, representing something in the outside world that it observed, or whether it's just some kind of random signal due to the model not actually knowing the answer. And luckily, there's a bunch of empirical work done have been done this already. So what does that empirical work say? So it turns out that language models can kind of do this. They do typically have confidence that is calibrated better than random chance. And here's a whole bunch of papers that have shown this. The biggest work came from Anthropic a couple of years ago. There was one from FHI, Wayne Evans and his cohort did a similar thing. And then there were a couple of other more recent papers exploring this question further. And these papers collectively used a whole diverse array of object level tasks, mostly like trivia style questions or math style questions. Um, and as an example of the strength of the signal here, can have a look at this little plot from the Anthropic paper. This shows a histogram of what they've called P true, which is the model's credence that it got the object level question right. The blue histogram shows the distribution of P true on questions that it got wrong, and then the green histogram shows the distribution of P true on questions that it got right. And you can kind of clearly see that uh, for the question that got right, it was pretty confident. For the question that got wrong, it was kind of less confident. So there's kind of clearly some signal going on here. So is this it? Can we interpret this as evidence for HOT2 for the discriminator in these models? Well, there's a couple of problems with interpreting these results in this way. One problem is that the PRM literature has its emphasis on the monitoring of specifically perceptual signals, while most of the object level tasks in this LLM confidence calibration literature is different, is like stuff that seem to be bottlenecked on other functions like memory or reasoning. So the main internal signals that are being assessed in this language model work is maybe more like memory signals or like thinking signals, and how much overlap do these have with like perceptual signals? It seems kind of unclear. Like in the human case, when humans are being tested for metacognitive abilities, they typically give them the object level task is something like they get given like a very short flash of some image, short enough to where it's like kind of maybe it's like difficult for them to work out exactly what they saw, and then they're asked like, was this like a picture of an apple or an orange or something? And in that case, like it kind of makes sense that like this type of task is bottlenecked on like being able to assess your perceptual signal from that thing. But with language models, it feels like pretty hard to work out, yeah, like what the equivalent, like analogous type of task would be. This kind of comes back to this issue of defining human concepts in language model terms. What the hell is perception for a language model? And what does it mean for a language model task to be perception heavy? Yeah, I spent a while thinking about this, uh, about what kind of tasks are like perception-y and rather than memorize-y or reason-y. The best I could come up with is maybe something like reading comprehension feels like a bit more perception-y because it doesn't really rely on memory or reasoning that much. It's more to do with like making sense of like something it's just seen. But I'm still pretty confused about how to think about this, and understanding like what perception actually means in terms of language models would be really big help for this particular work, but also I think for the field of AI consciousness more generally. Yeah, a second problem with interpreting this confidence calibration stuff in terms of evidence for a discriminator is that um, there's a whole bunch of alternative hypotheses for how these models are reaching or reporting well-calibrated confidences that don't require making any judgments about the reliability of internal signals. One of them could be if the answer to the object level question is in their context window. So if they ask the object level question first, and then the model answered, and then they asked the meta level question afterwards, the model could just look back at that answer and then just make a judgment about how correct that answer is, in the same way that it would judge how correct an answer from some other model was, without considering its own internal workings at all. Another possibility could be that it's simply assessing the objective difficulty of each question. For example, if the question was like, what is the capital of France? You'd probably be confident that you'd get this right. But if the question was, who was the king of Spain in 1800? You'd probably be much less confident. And this kind of reasoning too doesn't require any judgment about your own internal states. A third, more speculative hypothesis could be that models are reasoning about themselves via knowledge that they gleaned from the training data. For example, model may have read somewhere that language models similar to itself scored 50% on a math benchmark, and this would give it information about they could use to predict about how well it would do at a math question. And the common theme throughout all of these alternatives is that these are all extrospective explanations, where the model is doing this kind of reasoning purely based on external observations. Meanwhile, this hot 2 thing and this discriminator thing kind of implicitly requires the discriminator directly observing the signals that it's trying to assess the reliability of, not inferring anything about them from some external observations. In other words, hot 2 requires that the confidence reports came from some kind of introspective access to the internal signals that need to be assessed for reliability. So a natural next question is, well, can language models introspect? So far, there's only been one published piece of work that's produced some kind of evidence about this, and that's the situational awareness dataset of Lane et al. They tested the model's ability to predict how they would behave given some prompt. And they focused on prompts that for which the responses would be quite idiosyncratic to the model, such that being able to predict how they would respond in these particular cases could only be explained by the model like knowing something internal about itself rather than like reasoning about it via some galaxy-brained like I don't know, inference. And here's an example of one of the tests they did. They gave a model a list of 10 numbers, each with either true label or a false label attached. The labels were designed such that the pattern of the labels could be explained by 2 different possible rules. For example, in this case, the rule could either be true if number is less than 100, false if it's greater than 100, or it could be true if the number is odd, false if the number is even. And in this object level task, the model is given an 11th number and then asked to give a label for that 11th number, for which the model will have to make some decision about which of the 2 possible patterns to continue. Then in a meta-level task, the model has these two possible patterns described to it, and then the model is asked to predict if you were to be given this prompt, which of these 2 patterns would you have chosen to continue? And you can kind of intuitively see how the model there's no like useful information in the training data or or like in the context window that a model could use to infer this. Like the only way the model could know about this, and theoretically, could be like by looking inside itself in some way. And how do the models manage at this task? Yeah, most of the models they tried didn't score any better than random chance. But some handful of them scored marginally better than random chance, maybe around 55 to 60%. So we could interpret this as some kind of very mild evidence for some very rudimentary kind of introspection going on. However, it's not so clear whether this is actually the kind of introspection that we're interested in for this hot to indicator property. Because evidence that a language model can introspect on some aspects of their internals isn't necessarily evidence that they can introspect on other aspects. The aspects that we're interested in, like the perceptual signals. And this is kind of clear for humans, right? Like the fact that I can introspect on a thought I just had doesn't really imply that I can also introspect on some intermediate representation in my visual cortex or something like that. The test that we really need is something that kind of combines this kind of introspection test with the confidence calibration test that I was talking about before. So I dreamt up a little kind of experiment proposal that I think would more directly test ought to and more directly search for a discriminator. And this is very rough, and like obviously a real experiment would take a lot more iterations of like making this more precise and making it works. But the idea goes something like like you evaluate some model on some object level task. You measure the answers of that task, which I call this vector O naught. Where the vector is like where each component of the vector is the answer to each of the object level questions in your set of object level questions. And then after each of these object level questions, you ask for the confidence, how confident they are that they got it right. You measure those answers, and you get this other vector M naught. And then you do some intervention on the model that do some intervention on the model's internals, where get the model drunk or something, by like doing some random perturbation of its activations on forward passes. And then you do the same thing again. You evaluate the object level and meta level task again, collect another set of answers, O1 and M1 for when the model is drunk. And then you compare how well you kind of compare these two sets of answers. You ask whether or not the model can tell whether it's drunk. And so I believe that this is the kind of condition you would look for to confirm whether or not this thing has noticed that it's drunk. Where like a Breer score is just like something that measures how well calibrated a set of predictions are, given some set of outcomes, where like the first argument is the set of predictions of like how confident that it was that it got right, and then the second argument is like how it is like a kind of binary vector where it's either true or false for each component, and it's true if it got it right and false if it got it wrong. Another way of saying this expression is the model's confidence is when drunk predicts its performance when drunk better than its confidence is when sober, which can only be which theoretically can only be explained by gaining some extra information about its drunkenness once you get drunk. And yeah, this would be arguably evidence that the model has looked at some details about its internal activations and used that to make assessment about how confident it should be about each of these questions. Yeah, so yeah. Yeah, just to briefly mention that I traveled, I came across a whole bunch of other bits of LLM capabilities research that tested a bunch of capabilities that are kind of tangentially related to hot 2 or to the possibility of there being some discriminator type mechanism. I don't have any time to go into each of these here, but the headline is that language models seem to have been shown to be able to do many of the different components that a theoretical discriminator would have to do. But it hasn't yet been shown that it can kind of do all of these types of capabilities at the same time in some kind of integrated fashion. Yeah, so where are we? Where are we overall with this search at the moment? So in terms of the kind of external eval style evidence, we've seen that there's evidence of a bunch of tangentially related capabilities, but not yet any evidence of the exact things we would want to look for testing this indicator property. In terms of internal McInterpret type evidence, as far as I know, there isn't any McInterp work that pertains to something that looks like a discriminator. But I actually didn't look very hard, so if somebody knows something, some McInterp work that sounds like thematically similar to this, then I'd be excited to hear about it. Yeah, overall, it seems like there's some kind of very mild evidence of like some of language models like having the components that it would need to have a discriminator inside it. And then if I say, oh, let's have a pessimistic prior because like saying language models are conscious are like is like a wild statement. So I don't know, maybe like call it well, okay, I said 30% here, but I kind of pulled out my arse when I was writing these slides. Maybe it's like 10%, maybe it's like I don't actually know why I bothered putting a number here. I just felt like I felt obliged to say something about this to give some kind of credence. Yeah, so this is pretty much the end of the talk. What did I talk about? I gave a brief and sloppy description of my first attempt to direct one of these Butlin and Long indicator properties at language models. I came across a whole bunch of stumbling blocks, mostly related to the difficulty of translating these very human concepts from philosophy, psychology, cognitive science into machine learning terms. And overall, I think there's some very lukewarm evidence of something like a discriminator already. But I think some kind of targeted experiment would probably help us become a lot more sure about whether a discriminator is there, and therefore give us one little very mild update about whether or not language models today or ever will have phenomenal consciousness. And yeah, I have a draft report for this project in Google Docs, and if anyone wants to read more about it and give some feedback, then I'd be excited to show you. So get in touch if you want to see it. Yeah, cool. Thanks for listening.
Amazing. Thank you very much. Yeah, I guess we can go straight into questions. I'll give participants a chance to come up with something. I know I have a few, so I will jump in unless somebody is very keen initially, just to get the ball rolling. All right. Yeah, I guess I kind of want to get straight to the meat of it because I think it's really exciting. But yeah, so this experiment you're proposing, I think it's like I really like in the way that it like operationalizes and captures this notion of hot food. I think that's like pretty cool. Having talked a little bit to people who do this kind of like introspection work at the moment, the thing that they tend to find pretty much without fail is that LLMs are very poor at this, but with a little bit of fine tuning, they become quite good. And unfortunately, there's like a null hypothesis there, which is quite compelling, which is that it can like learn this ability, like it doesn't actually like deeply understand how to do this with fine tuning, but instead it like just like learns some like extra if clause on top of its original thing that just kind of like, so it's just like, oh look, if things make a little bit less sense than normal, report and drunk. Like you can just fine tune that circuit onto it, and that hasn't actually given it like a proper integrated kind of form of metacognition. And yet it also seems to be that given that this kind of type of question is not something that has ever been elicited from the model, it seems like implausible that you'd ever get something without any fine tuning. And so I think you're left in a weird position where you kind of want to fine tune it just to get it to understand what we mean by the question. But you don't want to fine tune it so to actually give it the ability that you're probing it for in like a hacky way. So ideally what you want to be able to do, and this is something that I think people just haven't figured out yet, is how do you come up with a fine tuning setup that gets the model to understand what the question means deeply without giving away the answer? So in this case, it's like maybe there's some other data set you could fine tune it on, which doesn't involve actually perturbing the weights, but like it just gives the kind of question format. So that's like a small detail that I think would be needed to make this work, because I think you'd find that you just get a null result initially, and then it's a bit like, oh, well, we could fine tune it, but that would just give away the answer. So I think that little detail is important. But I guess the question that comes with this, and the thing that makes me like hesitant or like a bit like nervous, I guess, when thinking about this, is whenever I try and come up with any kind of fine tuning, it always seems to have this property of either giving away the answer or it's just obviously not going to do it. And it kind of, to me, it feels a little bit like this concept like being like unusually slippery. It's like, have you seen that meme of like the raccoon who tries to wash its like cotton candy and it just kind of disappears in the water? That's kind of how I feel with this thing.
Yeah.
I'm always like at the point where it almost feels like I can have the experiment and then I like have to tweak some final detail and suddenly the like concept has completely disappeared in front of me. So I'm curious if you like feel some of that and if you have any ideas of how to get out of that in this case.
Oh yeah, definitely. I think, yeah, they kind of talked a little bit about like um trying to apply something like introspection to language models kind of requires some like uh it requires understanding like pretty deeply what introspection is. But introspection itself, like even before you start talking about language models and humans, like is actually like a really philosophically like fraught concept. Like it's kind of there's a whole bunch of debate about whether or not introspection is actually like a kind of a like deeply real thing, and whether it's like actually that different to other types of perception, other types of cognition or whatever. There's like philosophers who say that like there's actually no real difference between like between hearing like your own thought and like seeing or like hearing something externally. So the concept we're starting from is like it's kind of fuzzy and slippery anyway, and then like trying to take this very slippery thing and like design like a mathematical like kind of definition that we can like apply to like formal experiment, yeah, it's kind of not surprising that like yeah, anything which is designed as like, oh, this doesn't quite capture the thing, and it's because like the thing, the concept is like kind of fuzzy from the start. And
I guess like, yeah, a slight twist on that I feel like makes this maybe both more difficult but also more exciting is that, like, if you look at, in general, in the history of like philosophy and science, you often have these situations where you have these concepts which like are kind of fraught and it's not clear if they're actually pointing at anything or not. And then there's come the point where experimental scientists can actually start trying to operationalize and test these things. And often the concept that is tested is much more well-defined than the concept we started with. So like a really good example of this is like the notion of absolute space that was like hotly contested and has kind of been contested since like the pre-Socratics and the atomists talking about like the existence of void, or like Descartes talking about extension or whatever. But whenever you actually read anyone's writing on it, it sounds like they're grasping like they're kind of like grasping in thin air for these concepts. And then when you come like to the 19th century and people start like actually having like experimental tests they can do, they like have this notion of an ether, and then they have like these experiments which like go one way in the case of there being a kind of like background static medium through which light propagates, and they go a different way if like actually everything is just relational. You end up in a situation where like the experiment has actually given the philosophical concept more clarity. And I kind of suspect something like that's going on here as well, that like actually we don't have a notion of introspection that makes sense. But the kind of thing you're thinking about is the way to get to a better notion, like in the first place. So yeah, I guess that's like to say that that's not a reason to suspect that it won't be clarified through doing an experiment. It just feels like maybe it's like a much steeper hill to climb than most.
yeah, yeah, and some people say this about consciousness. Say that like we finally have like a difficult enough problem in like thinking about AIs that we're kind of forced to like take these for the ideas that are theories about consciousness and actually make them precise. And yeah, some people say that like AI is a thing that will push us to actually come to some real conclusions about what consciousness is. Yeah, maybe.
Not
Maybe
impossible.
that's yeah, it's not possible for sure. Yeah.
Cool. Do we have any other questions from either the room here or from our contributors? Dushan, do let me know if someone's asked a question somewhere that I haven't seen, because as we have found out in the last couple of days, I am not very good with Zoom. I guess give a minute or two for things to trickle in. We'll also have some time to talk in the breakout rooms in a second. If not, okay, I guess, yeah, thank you very much. Thanks again